And the first four terms in ascending powers of x are the binomial expansion of root 4 minus 9x. The general expansion is given like this, 1 plus x to the power of n. So we've got a little bit of work to do. First up, we can write it as 4 minus 9x all to the power of a half. But I've got a 1 here, 1 plus x, so I need to factorize out the 4 to make it 1 minus 9 over 4x. All of this is raised to the power of a half. And then 4 to the power of a half becomes 2, 1 minus 9 over 4x to the power of a half is what we want to calculate. So my x is going to be minus 9 over 4x. That's going to be x. And then the half is going to be n. So this is going to be approximately equal to, don't forget about the 2, then it's times 1 plus a half times minus 9 over 4x plus a half times minus a half all over 2. I'm just using this expression here. And then I'm squaring my x, which is minus 9 over 4x. Then one more term, half minus a half minus 3 over 2, all over 2 times 3, times minus 9 over 4 x, sorry, it should be that, then the bracket cubed. Okay, close bracket, square bracket there. We can simplify this, so I'm going to get 1 minus 9 over 8x. Put these in your calculator. I'll do this one, so just take it steady. I'm going to write 0.5 just to speed things up. So 0.5 times minus 0.5 divided by 2 times 9 over 4 minus 9 over 4 squared. That's the same as 9 over 4 squared. You can use the fraction button if you prefer, but this is just a little bit quicker. Minus 81 over 128 x squared. And the next one ends up being minus 729 over 1024 x cubed. And finally, this gives 2 minus 9 over 4x minus 81 over 64 x squared minus 729 over 512 x cubed. Jun uses expansion with x equals 1 over 9 to find an approximation for root 3. So when you sub that in, you will get root 3 in here, and it's going to be valid in the range because, well, its modulus of x is less than 1. We're going to have 9 over 4, x is less than 1. So we're absolutely fine there. But state whether this approximation will be an overestimate or an underestimate of root 3, giving a brief reason for your answer. So all the rest, well, we can see there's a positive 2 and then these are negative. Now every term from then on is also going to be negative because I'm going to be timesing by a negative like every single time here, but I'm going to be times by an extra negative here. So we'll get an extra 2 negatives each time, but the result is that the term will stay negative. So what that means is my actual answer, I should be minusing more stuff, which means our answer is going to be an overestimate. So all terms after 2 will be negative. Ignoring the ones after x cubed will mean our estimate is greater than the actual value. That's what I wrote when I did it. You really should add also, I didn't do this, since x is greater than 0, because that will have an impact. But x is positive, and so yeah, if I minus more stuff, it actually caused my answer to go down. Therefore, we have overestimated.